Alright guys, welcome to our second part of learning socket programming with Lee. So last time I released a video and you are learning just the basics of socket programming, and today we are going to advance on what we did last time. So let me just give you people a recap on what we did last time. So we were able to create a basic socket in which the server was the one sending data to the client and the client was able to receive it. But today we want to create a socket in such a way that we can connect both the server and the client in such a way that both of these devices can send data to each other, as in the server can send data to the client and the server can also receive data from the client and the other way around. And besides that, we also want to include another new part, and that's called threading. So threading is going to help us connect not only one device but multiple devices to our socket. So today I'm not going to use my Kali Linux, but I'm going to use Backtrack. Backtrack is just an older version of Kali Linux. My Kali is having a little bit of trouble. It's hanging and that. So I preferred just downloading the Backtrack image, and I'm using it on my VirtualBox. So this today will be my client. As you can see, I already have it up. And then my server is just going to be my local machine. And then I'm also going to connect the server to my phone. So today we are going to be working with 3 devices. The virtual machine, my server, which is my local device, my laptop, and also connecting it with my phone. So we're going to be able to send data and handle all these both these devices in the same with the same server. So yeah, let's get started. So as I told you that let's just get started with creating the server socket. So let me just create a new file and we're going to start. So inside here we're going to need 4 imports this time. Obviously it's the sockets import, the new the threading import. So we're going to import thread, and also we are going to import time, and also we're going to import system so that we can actually exit some of these things. So let's just get started. So what we do first is import socket, then we do import threading. So threading is going to help us connect multiple devices to our socket. So I'll just explain more as we go on. Import time, and now we import sys. So I'm going to show you what we're going to use this sys import for in a bit. So the first thing we do for our server is create a function that will help us handle the client. What do I mean by handling the client? That basically means receiving and sending messages. That's what our first function is going to do. So we're just going to create it. We are going to put a comment here. Create a client handler. So let's just define the function really quick. Define client handler, and then we're going to put our con and the address hub. So I'm going to show you where these two are coming from in a bit. So what this function basically does, it just receives messages and sends messages. Yeah. So the first thing I'm going to do is first print thread. I don't know, should we add the address so that we can be able to identify which thread specifically? So I think we're going to include our address here. So the reason we're including this address here is so that we can identify which client's thread is starting, since we have multiple clients that will be connecting. And then we move over to now receiving our message. So what our server will be doing first is receiving the messages. So to receive a message, you just do message equals to using con dot receive, and then we just put our buffer here. We provide a huge buffer so we can so inside here will be our message where it will be stored. So what we do next is, as you remember, whenever you send data over through a socket, it will be sent in bytes format. So what we're going to do is we're going to decode this message using decode. So let me just show you guys what's happening. So let's say, for example, our message happened to be bytes. This is a message. So let's say, for example, this was our message. If we check this message type will show us that the message is in bytes, and we want to print out this message, so we are going to decode it. So let's just store it inside m, and then put message dot decode, and by default it will just use UTF-8. We don't need to write it out. And then now if we print m, it will give us this is our message as a string type. So we can just check the type of m. It will show us it's a string. So this also works the other way around. If you want to send a message, you will have to encode it. So if we had that m and then we encode, it will give us it in bytes. So yeah, that's what we're basically doing. We received our message, now we're going to decode it and store it in message is equals to message dot decode, and then we finally print this is a message from, we provide which client give us the message by giving out the address. So let's just use a formatted string, and then we write, and it says, then into brackets message. And then I think we should also include a part here so that you can actually be able to identify the length of this message. So we're going to use the len function in Python. So if you want to find out the length of anything, you just type len. Let's, for example, use m, and you can find that m is 19 characters long. So if you count, you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, so m is definitely 19 characters long. So we store that len in a variable called length. Then we call the len on message. Then so that it looks kind of clean, let's not put it all in one. Let's just create a new line. Then let's name length is into bracket len. No. length. So we finished our part on sending the message. Let's implement a sleep so that our server sleeps for like 2 seconds before it receives a message. This first part was for receiving 2 seconds before it sends a message. Sleep for 2 seconds. And then now we start on our sending message part. So let me just add here, print receiving message from it's a formatted string. Yes, so that when our server is running, we can be able to identify like what's going on. So now we move part to the sending message part. So here is send message. So first of all, we provide the message itself to be sent. So that will just be message equals to. We could use an input function, but we're just going to provide the message directly. If we wanted, we could input the message manually, but I'll show you that thing in a bit. Hello, this is your server. Nice. So this will be our message which will be sent to the client, and we have to encode this message. So we put message, let me just name it dash underscore e so that we know it's encoded message. Message dot encode. Now our message is encoded. Then we proceed to send the message. So we just use con dot send. Then provide our message inside here. Yeah, so that's basically our handler. Then we do a time.sleep for another 2 seconds. And then now we close the connection. So after the server has, we should indicate where our thread is ending. Print thread, then we give the address so that we know which IP's thread is ending. Here I'll also put a print message so that we know that this our message is. Sending message to this address. Here we use a formatted string. So here, just close that. Let's not forget closing that. So yeah, that's basically our client handler. So what this function will basically do is it will receive and send messages. So that's only the basic thing that it does. Oh shit. Sorry. Now we move to providing our host IP and port. So you just type host equals to, we're going to use this IP. Is it that one? Just check. Yeah. Okay, 1.100. Port. Let's just use 8080 port as usual. Now we create our socket object. We're going to name it sock.socket socket socket dot af inet socket sock underscore stream. And after that, we're going to introduce something new. So this is the set sock option. So let me just show you what this set sock option is about so that you can proceed. So yeah, this is a set sock opt that we're going to introduce on this video. So what this basically helps us with is we want to reuse this IP. Let me just show you. We want to reuse this IP and this port whenever we want to create a new connection with a new client. So if we don't provide that set sock opt, this host and port will be bound to our initial client, the first client that connected. And whenever a new client tries to connect, it will give out an error. So that's why we are going to use this set sock opt. As you can see here, there are three parameters that we're going to use. There are also others here, value, buffer, but we're going to use this one. So it gives us a level, opt name, and value, which is an integer. So let's just read a little bit about it. Set the value of the given socket option. The needed symbolic constants are defined in the module, etc. socket Unix constants. The value can be an integer, none, or a bytes-like object. So here can be an integer, none, or bytes, representing a buffer. The case blah 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 blah. So don't think we should check this. Try to go there and see if we'll get more information about it, so that you can understand what this level and get so called. While manipulating socket options, the level at which the option resides and the name of the option must be specified to manipulate option at the socket API level. Yeah, so this is what you want. The level is specified as sole socket. So we want to manipulate this socket at API level, and the level that we are supposed to provide is this specific one. Then where's the second parameter, which is supposed to be TCP, the initiating connection size, the buffer pointed to option value. You're supposed to get this one too, but I'm not seeing it here. But I already have it. I read it somewhere. So let's just write the code so that you guys can see. So using our socket object sock, we do set sock opt, and then we do socket dot sol socket, and again socket dot so reuse address, and then our integer is 1. So this is going to help us reuse our socket for new. So it's going to help us reuse this same socket for connecting to different clients. Then now we move to binding the sock object to the host and port. So we do sock dot bind. Now we just provide the host, which is over there, and the port, and then we put a listen sock dot so that it can listen to clients trying to connect. Listen at an interval of 1 second. So every 1 second it's listening for a client. And we're also going to introduce something called sock.set timeout. So this set timeout is going to help us interrupt this entire thing in case we want to close the connection. Because earlier I had tried to create the entire socket without a set timeout, and whenever I wanted to exit the connection using keyboard interrupt, it wouldn't allow me because the socket was continuously listening for a connection and didn't really accept anything else. So that's why you're introducing this set timeout. So it listens for 1 second and then it times out for 1 second and listens for anything else, including keyboard interrupts and such and such. So I'm going to show you why we want to listen for the keyboard interrupt in a bit. Let me just show you first what a keyboard interrupt. A keyboard interrupt is a type of error that when you press Control and C, you see this error right here. You can also raise the error. You can also raise keyboard interrupt and you'll see. So a keyboard interrupt is a type of error, just like syntax error or name error. Yeah, so keyboard interrupt is a type of error that is brought when you press Control C. So most of the time people usually press Control C to end a program, but that's where we're going to use keyboard interrupt. So we're going to use keyboard interrupt to close or to interrupt our socket if we want to close it. So we just for our threads, we create an empty list so that this list will contain all our working threads when we create them. We use a try statement so that we can be able to catch all the errors, including keyboard interrupts and socket errors. So we use try, and then we use this loop while true. So while the socket is true, count dot address socket sock dot accept. So this is where our socket actually accepts a connection and then stores the value in con and address. So this is what we are providing here. As you can see, con and add, con and add. Now we move over to creating a thread. So let's first just print connected to address so that we know that we connected. Actually, can we use an if statement? If con print this, else print this, then break. No, let's not make it too complex. We'll include that in the next video, but it's a valid thing. So if you want to check if the connection actually happened, you could use an if statement. But let's just proceed with this first. So we are going to store our thread in T, threading dot thread, and then on the thread website, we see the threading module provides a way to run multiple threads or smaller units of our process. So what are these threads? So let me just show you guys an image. Threads image. I just Google it. Not that. Threads and processes. It's your threads. Yeah, so this is what a thread is. So let me just go there. So this is what a thread is. So a process is an instance of execution. That basically means is a process is your code while it's being executed. And usually processes have one thread inside. So as you can see there, this is a single threaded process. So if you just create any code, it will have a single thread. But since there is multi-threading in programming, that means we can run multiple threads of the same code. This makes our program much faster. That means we can run different parts of this program parallel to each other. That means each of them will be executing independently and parallel. So that makes it much faster. So that you can see here in a multi-threaded process, the code, data, and files are all the same, but all these threads have been allocated different registers, different stack, and different counters. So we are going to talk about this register, stack, and counters later on, but you just know that in a multi-threaded process, each of the threads are allocated uh, their own region in memory where they can have their own registers, stacks, and counters. But in a single thread, all the processes will have to run through this thread, and they'll just have to use one single register, one counter, and one stack. So we are going to talk about this registers, counters, and stacks later as we talk about assembly programming. Yeah, so in the future, I'll hopefully put out videos on assembly programming too. So let's just get back to the threads. Smaller units of process concurrently within a single process. It allows for creation and management of threads, making it possible to execute tasks in parallel, sharing memory space. Threads are particularly useful when tasks are I/O output bound, such as file operations or making network requests. So yeah, so this is why we're using threads, because it's quite useful when making network requests in such a way that you can handle different clients and different things at the same time without exhausting your resources, when much of the time is spent on waiting for external resources here. So I can just fill this here, the thread, target, and the argument. So this target part is basically the target function that you want this thread to run on. As you can see here, the target they provided us, crawl. So this is basically a crawler, a web crawler. So its target is crawl, and then the arguments provided is link and comma, which is just this. So we're going to use the same logic on our code. Let's just get back here. So we're going to provide the target. The target is this client handler. So you want to create a thread that can handle clients. Control Z. So whenever the thread is created, it handles a different client. So whenever the connection is created, a thread is allocated to that specific client, and then the thread runs the following function. And then the arguments to this thread is con and. So yeah, this is basically our thread that we've created. So every time a new client connects, a thread is created for that client, and then the thread runs the following code. So that will allow us to connect to multiple clients. So we just put t.start to start our thread, and then we append this thread to our empty threads list. So we just use all threads dot append t. So let me just show you how that append function works. So append is just a basic how to manipulate lists. So if you have a list of something, this for example, create our list called L and it contains nothing, and we want to put something in this list. So we'll just use append, but append is used in putting something at the end of the list. So let me do L dot append, then we put the character A. So now if you check L has A inside. If we want to append something inside L again, we can just do the same, but now change the value to B. So if you check L, you see that the append added B at the end, at the very end of our list. So that's what thread does. It just basically adds something to the end of a list. So we are going to add our thread to the end of this list of threads. So that's why we call this all threads, because it contains a list of all running threads. Then after, oh, I forgot something. We have to include here try statement so that we can catch this sock timeout. So I'm just going to explain that right now. Put an except socket time out. So this what this except statement here does it is when we call this sock timeout, it will raise an error, and we want to catch that error inside our function. So we don't want the timeout actually to interrupt our entire program, but we want the timeout to pause our program for like 1 second. That's why I provided one. Pause it for 1 second so that it can listen for a keyboard interrupt. So you see, as the connection is as the server continues on listening, it pauses for a second, and then that's when we can press the Control C so that you can exit our program. So we're just going to accept the socket timeout and just pass it. Don't do anything to it. And then accept. We now accept our keyboard. We now accept our keyboard interrupt. And then we print interrupted by ctrl plus C. And then now we do our sock, close our socket, sock.close. And then now we use our system exit so that we can exit the entire. At the end here, we're going to use a finally. So finally is a part of this try, except, and finally. So what finally basically does is finally will always execute in case of anything. So if anything happens inside this code, finally will always execute. So we want to include that so that we can always make sure that our socket closes. So that's why you're going to use it. If the sock object is still there, then we just do sock dot close. So this is going to make sure that our connection always closes. And then now we're going to join all our threads. What does join mean? So let's just go back here. I can show you guys. Join. Yeah, this join. Wait until all the threads terminates. This blocks the calling thread until the thread whose join method is called terminates. So what it basically does, it join. Let me just the attainment argument. What join basically does, it allows for all our threads to be synchronized. Let me say synchronized. What do I mean by that? when we created the first thread and it's running, when we join all these threads together, we created thread A and B. What it will basically do is it will allow for thread A first to run, and then thread A completes and then run thread B. So it kind of makes it more synchronized, as in each thread runs in an orderly fashion. Let's just say that. So for taking all threads, we do t dot join. So we join all our threads, and that is basically the end of our server side implementation of this socket. So this is the entire server part. Let me listen some time out. So let's just check. Let's just save it first. I'm going to save it. To reply. I think I had another server inside there. And then now we go to our backtrack. And then clear all this stuff. And then what we're going to do is just enter into Python. Python 3. Import socket. So we're just creating a basic client. So it's not too complex. Do sock equals to socket. And socket dot sock underscore string. Close that. So sorry. Sock dot. So we connect to the specific host. Provide the IP 192.168.1.100. And then now the port is 8080. Now it's listening for, okay, we have not run our server first. So let's run the server. We're going to run module, invalid syntax. What's wrong? Oh, okay. Client handler. So let's make sure that it's client handler, yes. Run. Run our socket first. So it's connected. You see, connected to this IP. This thread has started and it's waiting to receive a message. So let's send our message. Sock.send. Send a byte string saying hello. This is backtrack. Let me close that. And if I press it, you see it's written 24 there. It gets. Let me maximize this. This message is from the client and it says hello, this is backtrack, and the length is 24. And you see it's already sent a message. So let's receive the message from our client. Sock.receive 1024. So you see we've received a message saying hello, this is your server, nice connecting to you. So you see it has also closed the thread and it's waiting for other clients to connect. So let me also connect my phone so you guys can see. So on my phone, I'm using Tamax. So let me just open Python first. Import socket sock. I have to type on that. Create the socket object. As you can see, another client has connected. It's waiting to receive messages from that. So you can do send. We're going to send a message saying my phone. You see, just received a message saying my phone, and now it's sending a message to my phone and has already terminated the socket. So let's just receive the message from my phone. So yeah, on my phone, I've already received the message. So as you can see, we are able to connect and to maintain connections between different clients. Yes, not like last time we only had one client and the communication only went one way, but now we are able to send and receive messages and to connect not only to one but to two or potentially more clients. So yeah, that's an improved version of the previous code we just ran. So let's do the keyboard interrupt. You will see interrupted by Control C. So our server is working, it is up. We can run this server as many times as we want. We can connect devices to the server. We can send and receive messages. So yeah, so what have we learned today? We've learned about threading. Threading is the new thing that we introduced today. Threading helps us run multiple threads of a process so that we can connect multiple devices. So yeah, thank you guys. Si lazima like, comment or subscribe, but that's up to you. You all decide that. I just made this video so that we can learn together. So yeah, you people have a great day. See you next time.